Okay, you guys, let's go ahead and continue on. I know I said in the previous video that we were gonna go over question number 4, but let's do question number 3 since we already have the probability distribution. So if you remember from the previous where is it? Here it is. Okay, so this is the probability distribution that we got for X is the number of heads, and here we flip the coin 2 different times, and this is what we got, right? So hopefully this is in your notes. So we're going to use this to answer question number 3. Okay, so when I go to question number 3, it says, what is the probability of getting exactly 1 head? Okay, so look at your probability distribution, and what is the probability of getting exactly 1 head? Well, exactly 1 head is just 1/2, and that's the answer. Probability of exactly 1/2 is 1/2. And what I want you guys to write it, I want you to write it like this, and I'll go ahead and show you guys how I want you guys to write it. Okay, and this is what we call probability notation. So here it is. Okay, I want you to write it like this: probability of X equaling 1, because X was the number of heads. X equals 1 is going to be 1/2. That's what it is. That's how I want you guys to go ahead and write it. Probability notation. This is going to be helpful when we start talking about binomial. Okay, part B. What does part B say? Part B says, what is the probability of getting more than 2 heads? Okay, more than 2 heads. So let's look at our probability distribution. Probability of X being more than 2. Is it including 2? No, it's not including 2. So the probability of X being greater than 2. So the way that I'm writing it right now is like this. Probability of X being greater than 2, right? Because this means more than 2, okay? Is it including 2? No. Is there a possibility that it can be more than 2? No. If that possibility is not going to happen, then the probability is just 0. That's what it is, okay? Part C. Let me go ahead and move this over. Okay, so part C says, what is the probability of getting all heads? Okay, well, if I go back to my probability distribution, probability of getting all heads is just this one, right? Which in turn, if we go back all heads, right? A number of heads, well, the maximum number of heads was just 2, right? Me getting all heads is getting exactly 2 heads, right? So probability of getting all heads, so in other words, probability of X equaling 2 is equal to 1/4. Okay, that's what we get. Part D. Part D now says, what is the probability of getting at least 1 head? Okay, now when you say at least 1 head, you have to be very careful, because that can be at least 1 means above 1 or below 1. Well, the way that you can think about it is, well, what does at least 21 mean? If I need to go into the club, right, at least 21 means that I have to be 21 and over. So at least 1 means that I have to be 1 and over, right? So 1 and over. So I'm including 1, okay? So this is going to be probability of X being greater than or equal to 1, okay? And what is that? Well, it has to equal 1. So it equals this one, right, which is just 1/2, or 2/4. And it also, or it can be this one, 1/4. What I'm going to do with these probabilities, I'm just going to add them together. Okay, what is that? 3/4. So the probability of getting at least 1 head is going to be 3/4. Because I can get at least 1 when I get here. That's 2 of them. Or I can get at least 1 in here because it can be 1 or more. Okay, all right. So a lot of it in the terminology. Okay, all right. So now let's go to question number 3. So now let's really do, no, that was question number 3. Question number 4. Okay, so hopefully you guys really work this one out. Okay, so I roll a 6-sided die, right? The following can occur. I can roll a 2. So if I get a 2 or a 4, I'm going to win $10, okay? If I roll a 1, I lose $15, okay? If I roll anything else, right, I'm gonna lose. I don't lose or gain anything, so I got nothing. Okay, so what I want to figure out is, what is the probability distribution of the amount of money you win? Okay, so I'll just go ahead and leave it like that. Okay, so let me go back here so you guys can see. So I kind of wrote down everything that I needed, right? I wrote down. Let me move this a little bit further. Here we go. Okay, So I can either get a 2 or a 4 and I win $10. I can get a 1 and I lose $15. If I get anything else, then I lose. I don't lose anything or I gain anything, right? So I want to find the probability distribution of the amount of money that I win. So amount of money. So I'm going to say X is going to be the amount of money I win. Okay, amount of money. Okay, so that's just how much am I going to win. Okay, so right now let's just go ahead and make a table. The table is going to be the best way that we're going to go ahead and do it. Okay, so amount of money. So what is the amount of money that I can win? Well, I can win $10, right? What else can I win? I can win $0. Okay, what else can I win? I can win negative $15, right? So I'm winning negative $15. So basically I'm losing, right? But remember, it's the amount of money that I'm gaining, okay? Now, what is the probability? So what is the probability of all of these? Okay, so this, just be very careful. We are not talking about the dice. That's not what we're talking about. We're looking for the probability distribution of what? The probability distribution of the amount of money that we win, okay? So let's go ahead and figure out what all of these are. So what's the probability that I win $10? Okay, well, we know that we rolled a 6-sided die, right? And a 2 or a 4. Okay, so what's that probability? 2 out of 6, right? So I can get that 2 out of 6 times. Or in other words, 1 over 3. Okay? How can I lose $15? Well, I can lose it when I roll a 1. What is that probability? Well, that's just 1 out of 6. Okay? What is the probability of not winning anything else? Well, how many more options am I left with, right? So I already did 3 of these, right? So there must be 3 more. If I roll a 3, if I get a 5, or if I get a 6, right? If I get anything like this, then I'm going to not win anything or lose anything. So that's just 3 out of the possible 6. The reason why it's possible 6 is because we're rolling a 6-sided die, remember? 6-sided die. Okay. All right. How do we know this? We got this correctly. Well, let's add everything up. 2 plus 3 gives me 5. 5 plus 1 gives me 6. 6 over 6 gives me 1. Yay! Okay, so that's in that case. That's the probability distribution. This is it. That's all the answer. Okay? And that's all we got. Okay? So this is the probability that we're going to win or lose. Okay, so what's part B saying to do? Okay? So part B is saying, why is it not working? Oh, there it is. Okay. Part B says, how much money are you expected to win? Well, how do we find our expected value? Okay. So the amount that we are expected to win is the following. Okay. So I can win $10, 1/3 of the chance, right? Or I can win $0 with 3 over 6, right? Or I can win negative $15, 1 out of 6. Okay. What I'm doing is basically I'm multiplying the amount of money that I get times the probability. Okay. This is gonna give me how much am I expected to win in the long term. Okay. If I put that all into my calculator, right? So here's my calculator. I'm gonna go ahead and put it in here, right? You can put all of that in. 10 times 1 over 3. Right? Oops, I messed up here. So over 1 over 3. Then I do plus 0 times 3 over 6. Okay, then I do plus negative 15 times 1 over 6. Whoops. Okay, and I multiply that together. I can go ahead and press this. I get 5, 6, right? But I can go ahead and put this button right here, right? And that will give me the approximation. So I'm going to get expected to win 83 cents, approximately. This is how much I expect to win. Okay. Now, what we actually call this expected value. So whenever we want to find the expected value, and it's also what we call the mean, mu. Okay. So remember, same thing as X bar, but this is now what we call population mean, right? So the mean or the expected value is just equal to the sum of x's times the probability of x. Sum, remember, you just means I'm just adding them all together, and then after that I'm multiplying them by whatever that is, right? Okay. Now there's something else. Just with every mean, there's always an associated standard deviation. Now, the standard deviation in this case is sigma, right? And this is equal to, I can write it like this, SD of x, right? And that formula is just equal to the sum of x's. I'm going to subtract the mean, square it, and multiply it by the probability of x, okay? And then I'm going to take the square root of the entire thing. All right. Now, this is going to be a little bit more complicated to solve because we have to do all this stuff, okay? Now, even though they didn't ask to find the standard deviation, this is how you would find it, right? Now, let me write it over here, standard deviation. Okay, so whenever we have standard deviation, so it's still the same words that we used in the previous chapter. The only thing that's very different now is that now we have probability, right? So how do you solve this? By hand is such a disaster. I can go ahead and show you guys how to do it by hand, right? And in class, during class, I'll go ahead and show you guys how to do it in the calculator, right? So, because I don't want to go ahead and go over time. But basically what you're going to do, you're going to start off with your x's, right? Kind of like similar how we started off with the standard deviation. All my x's is 10, 0, and negative 15, okay? Right? Then what I'm gonna do is I'm gonna subtract it by the mean. Okay, so I'm gonna take 10 minus 0.83, right, which is what we solved over here. 0.83. Your expected value is the same thing as the mean, right? And that gives us 9.17. I take negative 15, subtracted by 0.83. That gives me negative 15.83, right? And then I take, oh, see, I already messed this up. 0 minus 0.83 gives me negative 0.83. Okay, let me just switch this around. This should be a negative 15. This should be a 0. Okay, see, I'm already goofing. Okay, so I get that. What's the next step? So after I subtract it, right, from the mean, I'm going to go ahead and square it. X minus mu squared. Okay, so I'm going to take 9.17 and I'm going to square it. Negative 15.83 and I'm going to square it. And then I'm going to take negative 0.83 and I'm going to square it. Okay, and when I put this all together, I'm going to get 84.0889, 250.5889, and then 0.6889. Okay, hopefully check my work. I did it earlier. So and then what am I going to do? I'm going to take all this, right, and I'm going to multiply it by the probabilities, okay? So I'm going to take all what I got in my third column, and I'm going to multiply it by the probabilities. Which probabilities? These probabilities, right? So this thing corresponded with a 10, right? And the probability was 1/3. So when I multiply this times 1/3, what I'm going to get is 28.029. When I multiply this 250 times the 1/6, I'm going to get 41.76. And when I multiply this times the 3/6, I'm going to get 0.34445. Okay? And what is the next step? I'm going to take them and I'm going to go ahead and add them together. That's what the summation says. I'm going to add them all together, and what I'm going to get is 70.13, I think. It's approximate. What's the last step? Square root it. Take the square root of this, and what I get approximately is 8.4. That's what I get. So hopefully I did everything correctly, right? I'm going to check my work right now. And that's how you would find the standard deviation and the expected value. Okay? That's basically all it is. I won't make you calculate this by hand. Heck no. I'll just make you use the calculator just like we've been doing all this time. Okay? All right. So that's it. And then I will send you guys one more video.